So now we want to change of base for the logarithms. Before we don't take theories, laws of logarithms. You take laws of logarithms. Those ones are not proven because you don't need to prove the proof. But if you need the proof, let me know. I will show you how they prove them. But change of base, we'll just reason them. What could reason them? So I get log of p like this, to base b. So make I call this one x. I just want to call this one equation 1, from our definition of log, we say the log of a number p to some base b is equal to x. Now what we talk, So given the explanation what we don't take for our log, it means say our p now equals to b raised to power x, If this one is like this, make I take the log of both sides. Taking the log of both sides. So make I just take the log of both sides, not the big deal. I will not say log p, log b raised to power x. This one can be to any base, to any base at all. It means say from here, log p like this, from here. Now if you use the theory of log, we say the third theory, say if I take the log of anything raised to power something, make I multiply the power by the log. So I will just do x is equal to what? Log of b, Now, from here now, make I make x the subject, I want to make x the subject of this one now. What thing will happen? I will get log p dividing both sides by log b. I will get log b, I will get log of b is equal to x, Now, more reason now from our equation 1. From our equation 1, what thing happen? Equation 1. Equation 1 tell us say our log x like this. Our x is equal to all of this one, So if we carry this one, come replace x for here, we'll get what? We get log of p over log of b, supposed to give us log of p base x. What do we can derive from here? We derive from here, we say, if you want to change the base, if you want to change base of any log, that means if I get log p base b, and then I want to change this base, the only thing I go do is say, I go just take the log of p to another base. If you call it base a, log of p to another base, any base of my continent, then I will divide them with the same base of b. So if I get log of p to base b, and then I'm not convenient, they're simple for me working with this base. I can change this base. So if I change this base, I will just take the base that is convenient for me. If not base 10, they're convenient for me. I will just take log of p to the base where they're convenient for me over the log of this base to the same base where they're convenient for me. I hope say it sync well. That's how we change base in log reading. Common logarithms, right? Common logarithms. Common logarithms, now logarithms, where we say their base na 10. Because normally our natural number na in base 10 will be. These logarithms they get two parts. So logarithm to base 10, they always get two parts. So the first part we go call an integral part. And that integral part we call them characteristics. The decimal part we will call them the Mathz. So now the two parts of common logarithms be that. You get table where we dey use find common logarithms of numbers. That one we dey call am four-figure table. Shey una know four-figure table? Una don hear am before. Four-figure table we dey use am find common logarithms of numbers. Abi? So if we dey use that four-figure table to express those numbers in their common logarithms, we go express them in two parts. So the log of numbers in common logarithms get two parts, characteristics and Mathz. Abi? Shey we understand am? Why would they use common logarithms? Common logarithms simple because every number can be expressed in standard form. Na im make we dey use common logarithms because every number can be expressed in standard form. Shey una know or do una remember standard form? Abi? So standard form, expressing number in standard form. For standard form, right, we go make reference to indices. You know say for indices, if I multiply 10 by 10, I will get 100. And then I will call am wetin? I will call am 10 raised to power 2, abi? If I express 10 by 1, I will call am 10 ba? And then this one is 10 raised to power 1 or 10 2, abi? So if I take 10 times 10 times 10, I will get 1,000, abi? I will get 1,000, abi? And then I will call am 10 raised to power 10, abi? Like this. Now, given this one now, right? We fit express any number as product of two numbers or two terms. One term go be in power of 10, and the other one go be the normal number. Make we check this one now. Like if I get 2,000 now, abi, I fit express this 2,000 as a product of two numbers or two terms, abi? Then I fit take this 2,000 now, I go say 2 times what? 1,000, abi? One part of the number or one term of the number, I fit express am in powers of 10, and the other one can still remain the way e dey. For example, this one now, I fit make am 2 times. Now I know that 1,000 is what? 10 raised to power 3. So I can have it as 10 raised to power 3 now. Now, this one now is 2 times 10 raised to power 3. Now it be our 2,000. So, our 2,000 like this. Now I don't express this 2,000 as a product of two numbers. Make we check this number. This number is 2.5 million, abi? I fit express this number as something like this. This number now, I fit express it as 2.5 times 1 million, abi? I fit express it like this. So I fit express this 2.5 million as 2.5 times 1 million. If I multiply these two, I will get back to this number, abi? Now I don express this number as product of two terms, and then we say that the other term can be expressed in powers of 10. So wetin be 1 million now? 1 million and 10 raised to power 6, abi? So I don express this one as product of two terms. Make we notice that these two numbers wey I don express like this, dem bin dey this form. These two numbers bin dey this form of a times 10 raised to power n. If we check out these two numbers wey I don express as product of two terms, where we say when we say, or where A, when we say A, they between, abi, A they between 1 and 10, abi. A they between 1 and 10. What do you mean? You mean say A na this part, abi, this part of the number expression, and this part of the number expression, na it be our A, abi. And then for these two numbers what I don express, the two numbers pass 1, but they no reach 10. Na wetin I mean. So the value of A go dey between 1 and 10, and this part na it come be n for here, abi. And our n come be wetin? Our n come be whole number, abi. Our n come be whole number, or wetin we call integer. So our A dey less than 10, and our A dey greater than 1. In fact, here we put equal to. So our A fit be 1 or greater than 1, and e go dey less than 10. Now, so wetin be the expression of number in standard form? Expression of number in standard form na when we express number as a product of two terms, where A is between 1 and 10, and then n is an integer. That's the expression of number in standard form. Now, why would they do all these things? This thing will help us find the logarithm of numbers in base 10, or help us find the common logs of numbers. Abi? So now we know how to express numbers in standard form. Abi? Another name wey they call number in standard form na scientific notation. Abi, in science, we dey use standard numbers in standard form very, very well. Why? Because it is easy to see the size or the magnitude of wetin we dey express, and then e no dey take much space. Imagine this whole thing, I can express am like this, e no take much space, and then with just one look at it, you don know the size of wetin I dey express. So e dey easy, e dey simpler, and then e dey help us to minimize error or mistakes for our calculation. Make we take examples. So we want to express these numbers in standard form, and then we say numbers greater than 1. All these numbers, they dey greater than 1. Abi? Make I add another example. This is F, and then make I add 2. So all these numbers, they are greater than 1. Abi? So we are expressing numbers greater than 1 in standard form. Look at this one. This one is 70. So we say that this A go dey less than 10. For here now, we just pick this one. 70 past 10, right? So we just pick 7. 7 is less than 10, abi? And the pass 1. Then we just answer by 10 raised to power 1, abi? And anything raised to power 1, now the same thing. So we just take 7 times 10. So we don't express am in standard form, abi? See this one now. This one now, we go just write 8, abi? 8. Now we put 0.9 because our A supposed to be less than 10. So our A now is 8.9. Then look at this one now. We put this point now. That means this point we move am from here. 1, 2, 3, 4. Abi? Now 4 places we move the point. We bring am come in. So we just say times 10 raised to power 4. Abi? Now so it be. So we don't turn this one to standard form. Look at this one now. This one now, now 55. Abi? 55 past 10. So we'll take 5.5 like this. Abi? 5.5. How many times we move this point from here to here now? 1 times. So we'll just say 10 raised to power 1. Now 10, 2. So don't move this one. Now see this number. This number get 9 zeros. That's 5 billion, abi? So 5 billion, we just say 5 times 10 raised to power how many? How many zeros? We get 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. We just say raised to power 9, abi? And then this one are waiting 2.3 million, abi? 2,300,000, abi? So we just say 2.3, abi, times 10. And then we'll count how many this thing wey dey after 2. 1, 2, 3, 4, 5, 6. They say raised to power 6, abi? That's how many times our point will move. 1, 2, 3, 4, 5, 6. So I'll do that. And then see this one. This one are 2. So we'll just say 2 times 10. Nothing will move now. So we'll say times 10 raised to power 0. For our next class, we'll look for how to express numbers less than 1 in standard form. See you next class and don't miss it.